Welcome to Rges Algebra 1. This is lesson 26B. We are beginning a new chapter now in algebra, and it will be chapter 11. And so we'll be talking about 11.1 and 11.2. And this whole chapter has to do with rational algebraic expressions. Rational expressions. Now, rational comes from the word ratio, meaning fractions. So we are thinking of fractions where you have an expression, not just a number, like 2 over 3, but an expression in the numerator, for instance, x plus 5, and an expression in the denominator, something like that, okay? Or actually a polynomial in the, I think we could have it with 1. In addition, I'm looking at what he's trying to focus on. Yes, we could have it in 1 also. And that would also, so in other words, if I had 2x over 3, x squared, that could also be a rational expression. All right, now that's the topic. The first thing you'd be asked to do is to evaluate. Now, evaluating is really pretty simple because I will give you a value for x, for instance. Let's say we have this over x plus 4. And I say, evaluate this, evaluate the rational expression if x equals 3. So I would simply, every time I see a 3, I would plug in, every time I see an x, I would plug in my 3, plug in this value, substitute it, right? And I'd get 3 minus 5, or negative 2 in my numerator, and 3 plus 4, or 7 in my denominator. And that's all there is to it. Let me do one more for you. Let's say I want to evaluate this. X plus 7 over x minus 2. And I want to evaluate it if x equals 5. So again, every time I see an x, I'll plug in 5. 5 plus 7 is 12. 5 minus 2 is 3. Don't forget to simplify it, and that would be 4. Now, there are a couple things that might go wrong, quote unquote. What if I had that same rational expression, that means expression with a fraction, and I want you to evaluate it if x equals negative 7. Well, notice when I have negative 7 plus 7, I get a 0 in the numerator. Now, it's fine to get a 0 in the numerator. And then I would have a negative 7 minus 2, or negative 9. So whatever I have in the denominator, if I have a 0 in the numerator, the whole answer will simplify to 0. The other thing that might be a little squirrely is, what if I had the same expression and I said, evaluate this if x equals 2. Well, to again plug in every time you see an x. 2 plus 7 is 9, but when I get to the denominator, I get 2 minus 2 is 0. And that should set off all kinds of dings in your mind, because we cannot divide by 0. It's undefined. Okay, we're not allowed to do that. It's illogical. Okay, so you would just say no value or undefined as your answer there. Now, the next idea would be, what if I had something like this, x plus 7 over x minus 2, and I say solve for x, or find x, if that whole thing equals 3. Now notice the big difference between what you just had above and this. What we had above this line were expressions. We just had the left side of this, but now I have an equal sign, okay? So I'm not telling you what x equals, I'm asking you to solve for x. Different idea here. Well, what if I had 2/3 x equals 9? What do? I'd either, well, I would probably multiply by the reciprocal, or I could think I would multiply by the denominator and then divide by the numerator. Now the difference here is because I have this expression, this has to be done, recall order of operations, before this. So I can't simply take everything, I could not take everything to the right side as a reciprocal because I've mixed my x's and my numerical coefficients or my number value. Okay, so what you're going to do is you're going to divide by the denominator. So you're going to be left with x plus 7, just the numerator. I could leave this parentheses around it or not. Notice I just had placed it in so you can see what's going on. I want to keep my numerator intact. Just leave it there. Take the whole denominator and multiply it so that I could take it to the other side. Just like that. Now what would I do? I would distribute through, I don't need that anymore, the parentheses, 3x minus 6. I would take my, and you do know how to solve something that looks like this now. I would take my number to the right side by subtracting. Minus 6 minus 7 is minus 13. I would take my variable to the left side by subtracting. X minus 3x is minus 2x equals minus 13. And finally, I would divide by a negative 2. I'm running out of room, sorry. And that would make it positive 13/2. I could also write that as 6.5. Okay. To check, you would go ahead and plug that in up here and down here. Okay? 6.5 plus 7 is 13.5 over 4.5. And if I did that division, I would get 3. Okay. So let's go ahead and do another one like that. Okay, let's solve this again. Remember this, I'm going to solve. So I'm going to solve by taking the denominator to the other side. Think of it as a grouping, so it's going to have parentheses around it. My numerator will stay on the left. Whoops, that should be a 10. I don't know why I put 11. Okay. Equals the negative 4. Don't forget, the denominator's a grouping, so I need to represent it with parentheses. Now distribute. Now take my number to the right. I could do this in one step if you want. Okay, to take the number to the right, I'm going to add 10. So negative 12 plus 10 is negative 2. To take my variable to the left, I'm going to add 4x to the original x on the left side. So I would have 5x equals negative 2. Divide, and you'll get x equals negative 2/5. No. I'm sorry. I thought I was talking it through, and I guess I failed to hit the record. What I did after this is I went ahead and plugged it back in to the original equation to check it and make sure that it will, in fact, equal -4. I've had to, once I have this, I have to be able to convert that -10 to a common denominator so that I can combine those. That's what I've done here for the numerator and denominator, this part here. And then I've combined them, but I still have a compound fraction, so I'm going to convert this. Remember, this means to divide, so I'm going to say that's the same as -52/5 multiplied by the reciprocal, and that's what you have right here. Canceling out your 5s, you're asking, does -52/13 equal -4? And it does, because 4 times 13 equals 52. All right, so sorry I had to repeat all that, so hopefully you didn't have to listen to it twice, but I'm not sure. All right, now let's go on to 11.2. In 11.2, we are going to talk about simplifying rational expressions, and so we're going to do that. There's going to kind of be 3 stages. The first stage would be if we had a monomial over a monomial. And so how would I simplify that? Well, I first look at the number part, and I say, what's the biggest number that can divide evenly into both of those? And that would be 5, leaving me with a 3 in the numerator and a 5 in the denominator. Now, working on my x's, I have 8 x's up top and 2 down below. If I were to cancel out, I would be left with 6 up top. Another way you can look at that is you're subtracting. Okay, the exponents. 8 minus 2 is x to the 6th in the numerator. Let's do a couple more. Okay, here I'm going to look at my number part first. What's the largest number that can divide evenly into both the top and the bottom? And that would be 12. 24 divided by 12 is 2. And 36 divided by 12 is 3. If I pick a number and when I'm finished, these things can still divide, then I did not pick the largest one, but no big deal, just divide again. But always check the numbers and make sure that they're no longer divisible. Now here I've got 2 x's in the numerator, 6 in the denominator. If you were to draw that out and cancel, like this, I would cancel one x, cancel another x, and I'm left with 4 in the denominator. Another way I could do that is choose which is larger. The 6, the denominator is larger. 6 minus 2 is 4, but make sure your answer gets to the denominator. Okay. Recall that? All right, now the next idea, so that's idea number 1, is how would I simplify monomials? 1 term in the numerator, 1 term in the denominator. Now, idea number 2 would be, what if I had something like this? And I have a binomial times a binomial. Remember, you can only cancel when you have factors, things being multiplied together. Okay. Well, I could treat this, it's one expression and the same expression. So because it is being multiplied by the second expression, the x minus 4, the x plus 4, these expressions, the whole expression can cancel out because it is a factor of the polynomial expression right here. Okay. So cancel those out, and my final answer is x minus 4 over x plus 4. Can I cancel this x and this x out? No, because it's not a multiplier, it is being added or subtracted. Something, right? The 4 is being added or subtracted to it. So I can only cancel multipliers or factors, recall that? Okay. So let's see if we have something else I can show you. In this example, what can I cancel? I can cancel the 2's. Let me write a few more examples. It's important for you to understand what can and cannot be canceled. In this next example, what can I cancel? I could cancel my 3's. In fact, I would like you to go ahead and make sure you have your book. Go to Oral Practice on page 462. Let's walk through this very, very quickly. Okay. And so pause it, get your book, come back, and we're going to do these orally. A, can canceling be done? Yes. What am I going to cancel? The x plus 3. B, I will cancel the 3's. C, I have to do a little mental arithmetic before I know what I can cancel. What can you cancel? For C, you can cancel out a 2 because I have 4 over 6 and 2 goes in evenly to both. So I cannot cancel out the grouping. I cannot cancel out that, but I could cancel a 2 out from both of those. So it's just asking what can be canceled. You don't have to do anything else, but figure that part out. Okay, D, you would cancel out your 2. E, it's a good question. Okay, here E says this. 2x plus 3, don't be fooled. 2x plus 3. Can I cancel this? Because there's no multipliers, cannot be canceled. Okay, now I could have distributed this, but I would not have gotten the same thing. Okay, I would have to get the same thing when I'm done down here. Okay, so there's no canceling. F, you can cancel your x, and you can also cancel with a little division in your mind, you can cancel a 4 out. G, I can cancel my x plus 4 grouping, and I can cancel also a 3. H, no factors, okay, or I can't manipulate it to a factor here. These are not the same. This has to be viewed as a group. I cannot cancel the x or the 3. I must cancel it as a group, so there's no canceling. I can cancel my x plus 3. J, I can cancel my x minus 2 and my x plus 3, so I'm left with 1 over 1, or 1. So J, make sure you understand J. The answer should be 1. You can't, well, the answer should be, they're just asking what can you cancel, and you can cancel both, everything. Okay. Now, K, you also have to do a little mental math before you can decide if I can cancel. Why? I need to recognize right away this is the difference of squares, so that really could be rewritten as that times that over the original denominator. Now this and this can cancel. See how that works? So study K, study J. Make sure all of those are simple for you. Now the last idea then that we have would be, what if I have a trinomial over a trinomial? I will have to factor the numerator and the denominator and then see if I can cancel. Well, in my numerator here, I would have to have a 2x and an x. Okay. And then I'll go ahead and do this by multiplying, right? We're going to get 60. What are my pairs? I'm looking for a difference of 4 or negative 4. Okay, I just tend to look here first, okay? Difference of 4. So 1 and 60 won't work, 2 and 30 won't work, 3 and 20 won't work, 4 and 15 won't work, 5 and 12 won't work, 6 and 10 will work. See how you do it? Okay, so now I need to have that, so I'm going to split this out to a negative 10x and a positive, that's negative 10, and a positive 6y. So I'm looking at these two. With a difference, they're going to have opposite signs. And in order to get a negative 4 when I'm done, I'll need the negative 10 and the positive 6. Okay. Now, factoring out then let's see, I'll put it over here and show you how to factor it. Remember here. Okay, I apologize because all the work is in here, but I didn't leave myself very much good room here. So in the second one, we're looking, when we multiply 2 by 15, we got 30. We're still looking for a difference of 7. So that would be 3 and 10. Split it out. So you can see you can't get away from this factoring now. We're going to be building on that from here on out. So here, once I get down to factored, from my original problem, I factor the two trinomials, and then I cancel. And so my final answer here would be 2x plus 6 over 2x plus 3. Even though I have these two x's in common, and I could divide out a 3 and my 3 and 6, it doesn't matter. They cannot be canceled because they are not factors. Very important concept. So there you are finished. All right. So that's really all the ideas. And so we'll have to make sure you review that. I'll go over it a little bit the next time. Also, the key is only cancel factors, and you still have to be able to factor accurately. So for those of you who are still struggling a little bit with your factoring, you must go back to Chapter 5 and Chapter 10 and nail that concept. That will, if you cannot get factoring, you will not be able to go forward successfully. So ask me as many questions as you need, but you cannot ignore factoring.